Good afternoon, everyone. My name is Mohan Iyer from the Vitiligo Association of Australia. I'm the Executive Officer, and today we're very happy to be hosting live events in Sydney and Melbourne. So we've got a half a dozen people here in Sydney and a room full of people there in Melbourne. And later on this evening, Perth is having an event as well. And we're celebrating World Vitiligo Day. Today's presentation is going to be recorded, so just seek your consent in doing that. If you've got any objections, please let your local host know. So today I'm just going to speak about the association briefly, about World Vitiligo Day, and some of our coming events. Then we're going to have some presentations by a guest speaker in Melbourne, and hopefully another doctor online is going to be joining as well. Before I begin, I'd like to acknowledge the traditional owners of the land where we're meeting on, or where you may be joining from today. Here we're on Gadigal land in the Eora Nation. We pay respects to elders past and present, and we recognise this and celebrate the diversity of Aboriginal people and their ongoing cultures and their connection of the land. And they've been here in this land for a very long time, and we acknowledge that. So, about us, the Vitiligo Association was commenced in 2010 from Perth, and it's spread now all across Australia. We've got representatives in all the capital cities, and we are a non-profit patient support group. We're also registered as a charitable organisation, and basically our aim is to minimise and eliminate the social stigma of vitiligo by increasing public awareness and assisting in the development of vitiligo education, research and collaboration. So we recently had a stall at the Dermatology Association's conference, and we were meeting people, doctors and things like that at that conference, telling them about the work we do. We're looking to hold more events like this where we can get people, patients, talking about how they can deal with the disease, and we want to hear from you as well later on, once we're finished with the presentations, on what we can do and how we can get together better. So recently, earlier this year, we've had a bit of a change of our structure. So our president, who's there on the extreme right, Dr. Adrian Ma, unfortunately he's traveling overseas at the moment, so he couldn't join us today. He's based in Melbourne, and he's associate professor at Monash University. In the middle of the top photo, Nada Karadzik is vice president, and from Melbourne we have Jennifer Nguyen and Katrina Tan, who are secretary. And we've got a new treasurer who's in the second from the left. Akhtar Hussain is the treasurer, and he's based in Sydney as well. Apart from that, we've got a lot of advisory members, and we're very happy to have Dr. Richard Whittle here from Sydney, and other advisory members in Melbourne. For the day-to-day management of the committee, I've been appointed executive officer. And we've also have a sponsorship officer called Heidi Castro. And in Melbourne, we've got Dr. Palomi Chowdhury, who's assisting with the support groups, and Dr. Angela May, who's in Perth. And welcome to Dr. Monisha Gupta, who's also one of the doctors from the Skin Hospital here. And she's joined online. So I'll just say a few things about World Vitiligo Day. It has its origins in India back in 2009 and was celebrated there on 19th of May. But then later it has got shifted with some work in Nigeria to the 25th of June. And incidentally, that's the same day when Michael Jackson passed away. And he was one of the famous people who had vitiligo, and he went for skin bleaching and things like that later on. So now it's been, since 2011, it's been celebrated on the 25th of June. And again, some of the aims of World Vitiligo Day are to debunk myths about vitiligo, because there are people who think it's contagious and things like that, to raise more awareness about the disease, and try to get the big pharmaceutical companies to be more interested in finding treatments for this. This year's theme for World Vitiligo Day is looking into the future, and it's placing emphasis on advancing knowledge and treatment of vitiligo. And there are a lot of around the world, we're seeing more people with vitiligo coming out on social media, and it's slowly getting more traction, which is very good. So we can see there's a picture there of a Aboriginal model, Sarah Reed Taylor from South Australia, and she a couple of years ago she toured Europe and all for her modeling. We've also got other models in Melbourne and things like that, which is really nice to see. So now we'll move on to our guest speakers. We're very happy to have Dr. Monisha Gupta, who's one of the leaders in vitiligo, in the field of vitiligo in Sydney. And later on, we'll hear from Dr. Christopher Chu from Melbourne. So, Monisha, are you ready? If you could just unmute yourself and then.
Yeah, thank you. Thanks, Mohan. Thanks for the invite, and thanks for organizing this. My apologies, I can't be there in person. So my message is simple for people with vitiligo, is to firstly say, treat it as early as possible, because emerging evidence shows that it's easy to switch off a disease when you treat it early. And I explain it like a rogue immune system. So say you've got a naughty child, you've got a year-old child, toddler who's misbehaving, and you just ignore it. And then this toddler, because it's easier to ignore than to intervene. And then this kid's 2 years old, and then it's 3 years old, and the misbehavior keeps going on because you've not addressed it. And then the child's 5 years old, and the child starts school. And now the teacher complains that this is your child is very misbehaved and doesn't fit in well with the classroom and things. And but this stage, you will need to have a professional intervention. Just good parenting is not going to do it. And so that's the thing with the immune system. Your immune system has gone rogue. It is misbehaving. It is attacking your melanocytes. So we need to switch it off as soon as possible. And in my experience, if patients present to us within 6 months of onset of the disease, we're able to switch it off and keep it switched off. The other thing that happens for a lot of patients is, so first is treat it as soon as possible. Then the second is treat it as long as required. A lot of patients, because these are chronic diseases, they will think, yeah, look, my colors mostly come back. I'm fine. I'll just stop. It's just too much of a commitment, going for light therapy, applying my creams. Look, it's expensive seeing the doctor. I think I'm feeling fine, I'll just stop. And that's where we have this role for maintenance treatment. Because unfortunately, at this stage, we have no blood test, no skin test to tell us if the disease is switched off completely. So when you and I think it has gone on the skin, it hasn't really gone away. It is still going under the surface. And I like to explain it like hitting the brakes. If you're driving at a high speed, you have to hit the brake, take your foot off the accelerator, hit the brakes, and keep your foot on the brake to stop the car from moving. If you try and take your foot off in between, your car is going to move forward. And then you think about your disease moving forward. So we've got, and depends on the speed at which you're going, and you can think about it as the speed at which your disease is spreading or how long it has been going on. So we need to hit it harder and keep it switched off. That's really important, the role of maintenance treatment, when a lot of people become complacent and then come back to us and say, look, it went away, but it's come back. So, and there is good research coming up to say that if you do the maintenance treatment for at least 1 to 2 years, the risk for relapse, that is the risk for the disease coming back, goes down. Now, the third thing is what's on the horizon. So unfortunately, at this stage in Australia, we don't have any Medicare subsidized therapies, which is a huge out-of-pocket cost for our patients. But there is hope, because it seems that the people producing tacrolimus, which is one of our commonest used medications, is going to soon become available in Australia. And I'm sure you're all aware of the buzz around this new JAK inhibitor, topical cream, JAK inhibitor. And there is hope that that will become available in Australia. And once it does become available, we are hoping that it is going to be PBS approved for treatment of vitiligo. So those are two hopeful things that are happening. What about the tablets that a lot of people are using around the world? That may be a little bit slower, because in other indications, even for where it is available for rheumatology indications and psoriasis, there are a lot of emerging red flags or signals to say that it may not be as safe as we thought. So we're going to just wait and watch and allow this process to take its course, because PBS fortunately looks at the data very carefully before making it available on Medicare. A very interesting question that one of my patients asked when I first met her. She says, "You're telling me it's treatable, Dr. Gupta. If it is treatable, why do I see patients with vitiligo? Why do I see in a market, when I go shopping, when I'm meeting people socially, why do I see people with vitiligo if it's a treatable disease?" And I think that is because the message that it is a treatable disease has not penetrated well. A lot of patients are dismissed by their doctors even, and are not treated early on in the disease. And there's certain patterns of disease which are harder to treat. So for instance, if you've got it around the tips of your fingers, tips of your toes, or your lips, those are sites that are harder to treat. And you do know at the skin hospital, both Dr. Whittle and I run a vitiligo clinic, where we've got camouflage options too. So sometimes the horse has bolted, so to say, and we get the patients to learn to hide their disease if it is embarrassing for them. So apart from medical treatments, apart from phototherapy, we're also doing, and we've actually made home-based phototherapy. We've done a large study on home-based phototherapy, where for patients with limited disease, we can offer them the convenience of treating their disease at home with a device where the nurse educates them about it. And then lastly, we're doing surgery. If people have got only, now the problem with surgery is unrealistic expectations. Patients think that they'll have large patches of vitiligo, a whole hand or a whole limb, and we will be able to just use a paintbrush technique and fill up the color. And that's where the problem is, that surgery in vitiligo is possible, it is successful, but it has to be, patient selection is the most important thing, where it is suitable only for patients with stable disease, which is their disease is not spreading, and has stopped responding to whatever medical treatment we are giving them. And then it is a small spot only. So small lesions, stable lesions are amenable to surgery. It isn't as if we can do large limbs with large areas with the treatment that is currently available. And again, surgical treatment is not covered by Medicare. It's out of pocket. It's not covered by private health insurance. I think as a group, as VAA, I think the biggest challenge we have is dispelling the myth that vitiligo is cosmetic. It is firmly a medical condition, no different from eczema, and has to be treated like that, and has to be covered by Medicare and PBS as a medical treatment, so that our patients can get the treatment early. They can treat it for as long as it is required, and the more research and the more novel treatments and targeted treatments that we hope will become available will be accessible to our patients. Thank you. So there is a lot of hope on the horizon. Research on the vitiligo front is progressing at a never before seen pace. And we're getting a lot of insights into what is causing it, how it is happening, and how we can prevent it perhaps before not just treating it. Thank you. Thanks, Mohan. That's me.
Thanks a lot, Monisha. That's really some very useful insights for all of us here. We're going to now hear from Melbourne. So we've got Dr. Chris Chu, who's a researcher, and Monisha mentioned a lot of research happening in the field of vitiligo, and leading that in Australia is Dr. Chris Chu, who's based from Monash University. So welcome, Chris.
So thank you so much, everyone, for the privilege to join you all today to present some of the research work that we've been doing in vitiligo, based mostly at the Alfred Hospital. Now, my name is Chris. I'll go into a little bit of an introduction about myself before we get cracking into the body of the talk. The entire talk goes for about 20 to 30 minutes. I hope not to bore you too much, but hopefully this will give you a little bit of light at the end of the tunnel as to the direction of the research that is going on in the field of vitiligo and what the future might look for patients both now and in the future. Now, the breakdown of our talk today is, number one, I'll just give you an introduction as to who I am. Number two, what do I do? Number three, what so far we've found in the lab? And number four, where to next? Now, I know because we are in different sites around Australia at the moment, in between section number 3 and section number 4, we're going to have a little bit of a break, and we might divide up between the different sites. So section number 4 might just be us in Melbourne here a little bit more intimately. So to begin, hello, this is me. That's my professional photo that I whipped out, and that's me in the lab, actually. Now, just to give everyone a bit of a background about myself, I'm a doctor. I'm going to be a dermatologist, and I'll be starting my dermatology training next year. Currently, I'm finishing my PhD in dermatology, which I started 3 years ago. Now, my story in the field of vitiligo is actually quite interesting, because while right now I've been working as a doctor for 6 years, and I've been doing my PhD in my 3rd year now, my story in vitiligo actually started in 2012. Where at the end of my year 12 exams, my mum noticed that I had one white eyelash. And at the time, I had no idea what vitiligo was. At the time, I was told, you know, should be okay. It's just one white eyelash. What could that lead to? What could that be? Who knows? And that one white eyelash inevitably led to 2 white eyelashes, 3 white eyelashes. Then eventually, all my eyelashes turned white on my left eye. Now, some people called me a little bit like a Dalmatian or a zebra at the time, because my eyes looked slightly unevenly sized because I'd lost eyelash on the one side, and then it moved to my eyebrow. And, you know, at the time I was just 18 years old. My mum thought, you know what, we better go see a dermatologist. And I went to see a dermatologist at the time, and I was told really there were 3 things, okay, 3 things that came out of that conversation. Number one, I had vitiligo, and there was nothing that I could do about it, because it was over my eye. And as most of you know, the main treatment for vitiligo includes, you know, topical therapies, which I can't put inside my eye, and UV light, which I also can't put in my eye, because that would obviously lead to things like cataracts and obviously have a lot more harms. I was also told that, you know, the reality is that vitiligo is also associated with a number of other conditions. I was told that maybe you might develop diabetes at some stage, maybe you'll have thyroid problems, maybe you'll have rheumatoid arthritis. But there's also nothing you can really do about it except for watch and wait. I was given a blood test slip and told to go on my very merry way and hope that nothing happened. And number 3, I was told that no one really is studying vitiligo, that really there weren't really many efforts being put into understanding this disease further, because the reality is, and the reality was, that is just cosmetic. Yeah. Oh, I need
just wanted to see your
my full head. Okay, that's all right. Ah, no worries. What I might do is I might push this a little bit further away and stand like this. How does that look? Oh, actually, no, that's. I'm just gonna make this look a little bit more professional. What we do, we'll move this across. Oh, it's not tall enough. Like this. How does that look?
Oh, beautiful.
More or less. Okay, we'll do our best. So that was my story with vitiligo. I was told that people aren't looking into it. It's just cosmetic. There's nothing you can do, and it might get worse. Now, I count myself extremely lucky because while I was told all of that, over 10 years ago, I've been very fortunate that the vitiligo, segmental vitiligo, has just affected me around my eye. It's progressed and come back and progressed and come back. And it's, there's been this relapsing, remitting course that you might have all experienced at some stage. But I've been lucky that it's just affected me there. Now, at the time, I actually didn't know I wanted to do dermatology. I didn't know what really else was in the field of dermatology. But as I went through medical school, I became a little bit more interested in dermatology, to the point that in 2019, that was me at the end of the Run Melbourne, where I'm not sure who else was involved, but we were raising funds for vitiligo research, actually, with somebody that many of you may know, my very close mentor, Professor Adrian Ma. And basically, a lot of my story of vitiligo was inspired by Adrian, who inspired me as a medical student in 2016 to think about a career in dermatology. And that led to my interest in vitiligo and to where we are today. So what do? Everyone has heard the word research 1,000,001 times. You read it in the news, you look at it and you see it online, you can read articles everywhere that say the word research. But sometimes it's a little bit hard to contextualize. When someone says, I'm doing research in vitiligo, what does that actually mean? And what is that research actually doing? And I'd like to just break that down for you a little bit so that we can have a better understanding as to where the field of vitiligo research is going. So number one, I'm trying to gain a better understanding of the system of skin pigmentation. Not just the disease itself, but what do pigment cells do in the skin, what they are doing when they work well, and what happens when they're not working so well. And that includes everything from melanoma, which is an overgrowth of pigment cells, all the way to vitiligo, which is where the pigment cells become inactive. Number two, why is this system compromised in vitiligo? Why do some people get it and not others? And number three is what can we do to study vitiligo better and then to treat vitiligo in patients both now and in the future. So a little bit more graphic now. When someone says they are doing research, it's really important to understand what that word actually means. And broadly speaking, and the work that I do, we can actually break it down into 4 parts. And this gives you a bit more of a context when you think about someone doing vitiligo research or research in any field, what they're actually doing. So on the left, we can study patients. And this is what we call clinical research. This is what some of you may have heard about before with things like clinical trials, where a real patient has a therapy or has a treatment or has something done, and we look for clinical outcomes. Is there an improvement in skin pigmentation? And unfortunately, as you all know, the trials of vitiligo have been fairly limited across history. There's some new trials that are coming out more recently. But the other unfortunate reality is many of those trials are just repurposed drugs from other conditions. So things like the JAK inhibitors that you may have heard about were initially designed often for rheumatological or immunological conditions, which we're trying to repurpose into the condition of vitiligo. And a lot of the time, these treatments weren't specifically designed for patients with vitiligo. We're just hoping that it also works. So that's clinical research. Number two, we can study tissue. Now, it's really important that we recognize that we as humans have conditions, but when we have conditions, something is actually going on inside the skin. And it's important to actually understand what's going on. And what we do and what I do is I study human skin as well as animal skin, typically mouse skin, to understand what's actually going on in the body when it's working and when it's not working. We can also study cells. We can collect those cells from both humans and animals, and we can grow them, study them under the microscope, and understand what happens to them in different conditions. And finally, we can study parts of the cells. That's everything from genes to RNA, which everyone's now heard of since the COVID vaccine's been created, also proteins, and understand what's actually going on inside the cell that might lead to this disease. Now, why am I showing you all this? I'm showing you because in order to treat vitiligo, we first need to understand it. And once we understand it, we can then work our way backwards to treat it. And really what I'm hoping to do with my research, and what I'm hoping to partner with VAA and patients with vitiligo to do, is come up with a way for us to pursue and progress in this field and come up with future treatments. All right, now where to next? Now, if you're in Sydney or somewhere else around Australia, this is the section where we're planning on, I think, dividing into our different sections. So is there anything else that we've got to do, or?
Mohan, would you like to ask any questions or say something?
Or feel free to hang out together if you'd like. We can do the whole talk together if you prefer.
Yes, so thanks a lot, Chris, for that presentation. We might just take some questions. I'll just ask for that. Before I do that, I'll wrap up here and just say a big thanks to the Skin Hospital for providing the facility here, and also to the Skin Institute in Melbourne, who are doing a similar thing in Melbourne. So a great thanks, and thanks for all the people who took the time out on a Sunday to come out here. Just wondering, we'll just check in Sydney if there are any questions for you, Chris, while you're still there. Yeah, so just hang on.
Is it possible to re-inject them, or to have some sort of stem cell injected into that area?
Okay, so the question was, if those cells are totally gone, can we have an injection or something to do something to the stem cells to generate them?
Yeah, so really good question. So there's basically three ways that we hypothesize we'll be able to treat vitiligo more effectively. Currently, all of the current treatments focus on the immune response and the autoimmune activity around vitiligo. What we want to do is actually develop treatments targeted at the pigment cells themselves. So yes, answer number one is transplantation or transfer of pigment cells from another part of the body. That is an effective way at treating vitiligo. We are planning on doing some optimizations to the standard therapy in order to actually keep more of these rapidly dividing melanocytes alive in the transplantation process, because basically if we can keep those cells alive and we can make sure that those cells get transferred, it will be much more effective. So that's number one. Number two is this particular protein which we are studying, which marks these dividing melanocytes, actually has known peptides in the skin, so proteins in the skin that help to turn them on and off. So if we're able to actually develop a way of activating this population or retraining pigment cells around the vitiligo lesion to become more active, we might be able to bring that population back, almost like training an army of soldiers to re-invade a territory that has no longer been habitable. And the third one is actually melanocyte stem cells themselves. Now, these actually live in the hair follicle, and many patients may have heard the important kind of pattern of vitiligo, which is where if the hair loses its color, it's often much more difficult to bring the color back, and that is because the stem cells may be affected. Now, if we're also able to target those stem cells or turn those stem cells back on, we might have an additional place that we're able to recruit pigment cells from. So those are the three kind of broad directions that we're going to head. And actually, I'll just quickly jump through a few slides. If you're in Sydney, just because you won't be here till the end of the presentation, I am starting like a little bit of a mailing list specifically about my research, but also because there's a bit of a partnership that we need to build in around vitiligo, which is it's really difficult to study a condition if we don't have people to study, but if we also don't have the tissue to study. And one of the things that I do in the lab is I look at the skin of patients with vitiligo to better understand what's actually going on inside, and one day hopefully translate back out into treatments for real patients. So if you're interested in one day participating, or you just want to keep in touch, there is a QR code on the screen over there. I edited it in such a way that it was supposed to look a little bit like vitiligo, but it didn't turn out as well as I as I hoped. But feel free to scan that QR code and pop in some of your details, and we'll keep you in the loop. Any other questions from Sydney?
Any advancements on DNA research?
So the question here was, any advancements on DNA research?
DNA research specifically in vitiligo, or just more broadly? Sorry,
specifically vitiligo, yeah.
Yeah.
Oh, in vitiligo. So there has been a number. So actually, the big challenge here is we need to understand in a vitiligo patient, not just the genes that are there or not there, but which genes are active. And I think where there's been great challenge is actually understanding the genes that are actually, you know, important and relevant for the development of vitiligo. So there's been a number of genetic studies and kind of DNA-based studies which look at basically single DNA genes that have been swapped or altered in whatever way, and that may result in lack of protection against oxidative stress and a predisposition to autoimmune diseases. But understanding those genes, unfortunately, doesn't really translate into future treatments unless we know what the downstream effects are, so we can then undo those downstream effects to create a situation on the skin where the vitiligo doesn't develop. So there have been a number of advances, but I think one of the things that would be great to look at is actually matching the genes with the actual activity in the same patient, so we can understand actually, as a result of those genes, which are changed or altered in whatever way, what is the actual effect that it has on the patient and on the skin.
Okay, thanks. Any other question? Yeah, one more question here.
Thank you. I don't know if Chris can hear. Chris, thank you so much for your presentation. That was really insightful and fantastic to see the work that you're doing. As a person with vitiligo, multi-generations through the family and chronic, and I was just calculating after I'd mentioned 20 to 25 years of being a vitiligo sufferer. Actually, I think it's more like 30. I suppose having it chronic and throughout my whole body, you're talking about lesions and sort of more, I suppose, individual places. I'm wondering what possibilities there are either to stop or alternatively reverse vitiligo for people who have had vitiligo chronically and on a long-term basis.
Yeah, so that's probably one of the final bastions in a way for vitiligo treatment, which is, you know, if we have just one patch, you know, there are many options that we can use to treat that. But it sounds like in your case and in many other situations that option may be much more challenging due to the extent that is affected. And that doesn't mean we should necessarily give up. I think there is still always hope. It just means that the options may be a little bit more challenging and a little bit further away. But just to kind of give you a bit of scope as to what the potential options could be. So one of the areas in the lab where I'm trying to refine our technique is actually the ability to grow human patients' pigment cells, where we can actually harvest skin from a patient and actually grow them in the laboratory so that we can go from 1,000 cells to 1,000,000 cells and beyond. Now, in theory, if this technique works extremely effectively, it means that a very small area of skin could potentially be transferred to a very, very large area on the body. And currently the numbers that have been floated around the literature, and it's not exactly perfect, is a 1:10 ratio if you don't grow the melanocytes, but a 1:100 ratio if you're actually growing the melanocytes. And if you grow the melanocytes really, really well, and you grow many, many pigment cells, in theory, just like a farm, or if you have seeds, or if you're growing an orchard, you could technically just keep growing more and more and more if you have the right resources. So that is one way that it could be approached, where we can say, okay, there may not be many pigment cells left, but potentially if we can use tools to be able to expand that and grow that out outside the body, we may be able to put that back in. But at the same time, there is the important thing where if we're ever going to do a transplant, or if you're ever going to move cells from one place to another, we want to make sure the place that the cells are going to is a hospitable environment for the pigment cells to grow. And that might mean finding ways of ensuring and guaranteeing and confirming that the skin doesn't have, you know, leftover enemy soldiers and the immune system still active to ensure a good outcome. But yeah, I think it's definitely a challenge which I would love to find a solution to. I don't know how long it's going to take, but yeah, definitely if you want to find out more about where things are going, I currently grow a fair few pigment cells in the lab. I do it every week. Feel free to reach out.
Yeah, so Chris, if you've got any questions there, you want to take them?
In Melbourne?
Yes.
Yep. Melbourne questions? Oh, yeah.
And if you do grow those cells, what's the survival like? Will they be forever?
Oh, as in, so the question was, if there are cultured or grown pigment cells, will they last forever? So currently there hasn't been many places in the world that have grown pigment cells outside of the body and then put them back into the skin. We know that no cell lives forever, so but we do know that there are ways that we can help them to live longer, but help them to also maintain their dividing function. Because it actually doesn't matter if a cell lives or dies as long as it can get replaced. If it gets replaced, no problem, because it means that effectively you've still got the cell there, and as long as it functions, then the cell there, the cell functions, the skin will return back to its normal phenotype, or how it should look is what we hypothesized. So I think the techniques to be able to grow pigment cells still needs to be refined. I think there isn't really any labs in the world that have really mastered it to the point where they can confidently take one patient per, you know, one credit card sized piece of skin and turn it into 1,000 credit card sized pieces of skin. That hasn't yet been done. But, you know, I think as the technology improves, as our technique and our skills improve, that might become more promising. Yes.
I just want to know that is there any basic cause of that vitiligo that is causing we are getting the vitiligo? I mean, I want to know that why we are getting vitiligo, the general cause.
Yeah.
Is that vitiligo transferred to the gene to the next generation?
So basically the question was, what is the underlying cause of vitiligo, and is it inheritable? Does it pass on from generation to generation? So actually the middle section of my talk, and I don't know if Sydney, if you want to stay on this conversation, maybe we can just, what are your thoughts, Mohan? Should I go through the rest of my slides and maybe just we'll do the rest together?
Yeah, I think they're interested. So if you could finish your slide, that'll be good.
Okay, yeah. Even though you are, you know, 800, what was the number? There's a sign. There's 889 kilometers, I think. There's a sign in Melbourne that says that's the distance to Sydney. Even though we're 800 kilometers or 900 kilometers away, I still feel like we're just next to each other. What, you know, technology does these days. All right, let's quickly go through the last few slides. So where to next, everyone? So we're going to do a couple of very simple A and B multiple choice questions, all right? What we're going to do here is, including Sydney and Melbourne, on the count of 3, I'm going to get everyone to yell out either A or B, all right? So skin pigmentation is due to the presence of pigment known as 1, 2, 3.
A.
A, well done. It is melanin. Now, I've been playing around recently with some AI image generation, and I basically put the word melanin into the software, and it gave me these images. Now, melanin is indeed the substance which gives skin its color. Number 2, skin color is due to presence of melanin in either A or B. Here we go. 1, 2, 3.
A.
B. Oh. So here's a little bit of fun educational information. Now, most melanin, the chemical itself, is located in the melanocytes. So I tricked everyone because melanocytes come from the pigment-producing cells. But these pigment-producing cells are not very common in the skin. And in fact, if you take out skin from any patient with or without vitiligo, you'll find that these pigment cells, which live here at the bottom layer of the epidermis, the top part of the skin, they're fairly infrequent, but also they do an important function, which is share the pigment with the other nearby skin cells. The reason why a part of your skin is colored or not colored is not because of the cells being gone. Yes, the cells are gone, but the reason why you can actually see that is because all of the other cells there have lost their pigment. That means that by the time you actually see the pigment being lost in your skin, that's not a marker of the pigment cells being gone. That probably happened a while ago. What you're seeing is all of your other skin cells, what we call keratinocytes, which normally hold that pigment and protects the nucleus in those cells. Those cells have been shed off, and now you have a white patch. And you can actually see that over here. You know, B is a section or biopsy taken from a section of skin that is pigmented over here, one of the patients said we looked after. And you can see that these cells are melanocytes, but the brown color is actually around here. The brown pigment color is actually not inside the melanocytes. The brown color is actually in the keratinocytes. It's in the neighboring skin cells. And if you compare that over here to biopsy C, which is taken from a section of white skin, you can see that, yes, we lose the melanocytes. There are no melanocytes in there. But as a secondary outcome of that, that means that the pigment itself is no longer able to be produced, and therefore the skin itself loses its color. So that's really important to recognize, is that what you see on the skin is a later manifestation of something that's already happened. That is different from conditions like eczema or psoriasis, where inflammation leads to redness pretty much straight away. You can almost see it, and it's itchy and it's active, it's there. Vitiligo, on the other hand, can be very subtle, because behind the scenes, completely without symptoms, the pigment cells are dropping off one by one, leading to later loss of the pigmentation itself. Yes. Itchiness.
Sometimes like I sort of when it's getting more again.
Yeah. So the question is itchiness associated with vitiligo. Typically, vitiligo won't present with itchiness. So for the vast majority of patients, vitiligo is usually asymptomatic. However, there can be an overlap because there is some autoimmune activity going there. Those cells can cause inflammation, and if they do target any other cells in the layer of the skin, it can cause inflammation. Some people can get eczema on top of that. Some people can have other skin issues associated with that. But purely vitiligo, the targeting of just the pigment cell, if we purely talk about that, in theory should not have itch. Did you have another question?
Go ahead.
Yeah, and what I'll go through in a few more slides is if you do have itch on the skin with vitiligo, that can actually lead to worsening of the vitiligo due to trauma that the scratching actually causes on the skin. And we can kind of talk through why that happens. But all right, let's go through the story. So this is why does vitiligo occur? And the entire story of vitiligo is actually extremely complex. And I've looked through the story from every direction, and actually it's a very remarkable disease, and it's an amazing disease to study, and I feel very privileged to have the opportunity to explore this in more detail. Now, just to kind of give everyone a bit of an understanding as to what's actually happening inside the skin, is the loss of pigmentation that we see on the skin as a patient or as a doctor is usually a late manifestation of what's already been happening in the skin, usually for at least a month, if not months, before the time that the skin loses its color. What happens at the start is, for a number of reasons, trauma. So if anyone's ever noticed that they develop vitiligo in their kind of armpit or in their groin or places where there is frequent friction, trauma can cause stress on melanocytes, what we call oxidative stress. And there's a lot of things that can cause oxidative stress. Even if you slap yourself on the hand right now, your skin has to respond. And as part of that response, there are some chemicals and free radicals which are naturally produced in your skin, which causes your melanocytes to become stressed. But stress can come from other causes too. Chemicals can cause stress. So if you've ever heard of depigmentation therapy or bleaching therapy, there's a chemical called monobenzoate ether of hydroquinone, or MBEH, that actually directly causes stress in melanocytes. And that's why it works as a bleaching therapy. But also genetically, and this is important for anyone who has, for example, a number of family members with vitiligo or a number of family members with autoimmune conditions, some people and families, and there are some genes that can be passed on. And, you know, unfortunately in vitiligo, there are too many genes. There's no one specific gene that causes vitiligo. So in theory, there can be heritable and non-heritable versions of vitiligo, and we just don't know enough yet to know what's the specific gene or gene serve. But effectively, your genes predispose you to vitiligo. So some of those genes make your cells less good at coping with stress. It means that while someone else might be able to handle that amount of friction or that amount of stress or that amount of chemical, but your skin might be much more sensitive, just like some people are sensitive to certain makeup or chemicals or creams. You might be sensitive to the stress that is caused by various environmental factors. And similarly, those genes can also lead to an increased rate of autoimmune disease. And therefore, when you have stressed melanocytes, what we now know, moving on to the middle part, is these stressed melanocytes send out signals to the body. And these signals usually get sent out by viruses, by bacteria, as kind of warning signals to say that, hey, I'm a foreign invader. And unfortunately, in vitiligo, stressed melanocytes send out very similar signals to a foreign invader. And what your body will then do is target those cells thinking that it's a foreign invader in an autoimmune process. There are a number of ways that these cells kind of die in other ways. So they can die due to things called apoptosis or necroptosis or pyroptosis, which are different programmed cell death pathways, basically ways that the body uses to protect itself from what it thinks is a foreign invader. And melanocytes also often detach from the skin. So inside the skin, you've got many layers. It actually detaches from the places where it's meant to live. And as you can imagine, if something's meant to be stuck on and it's now floating around, it's probably not going to live so well. Now, once that happens, this middle part, effectively, the pigment that's already in your skin will stay there. It's just that the next round of skin pigmentation will no longer be able to be made. And that's the important thing to think about. Whenever you're developing, say, if you develop a new patch of vitiligo and you have new acute or progressive vitiligo, what you are seeing is something that's probably already transpired a month ago. Because it takes typically about a month for the entire, top layer of the skin, what we call the epidermis, to replace itself. Because every day, the dust that comes off our skin is skin cells, which were there, which have slowly become more and more old and eventually fallen off. It takes about a month for that process to happen. So by the time your skin becomes white, it means that the pigment cells were lost a month ago, and a month ago, there was no more pigment to be shared. That's really, really important, and we'll talk about how treatments can be used to address this in future. Now, for many of us, the autoimmune targeted divided melanocytes, for many of us, this phase doesn't last that long. Okay, it might last a few months, but usually most patients reach a point of stabilization. And when we get to this point of stabilization or loss of pigmentation, then the goal is actually to reverse this process. How do we get these cells to grow back? And because, as we mentioned before, that basically this autoimmune process targets the rapidly growing cells, it makes it really, really difficult to grow the pigment cells back because all of those growing cells just aren't there anymore. That means we get treatment failure. That means we get progression. That means we get relapse. That means the autoimmune activity is ongoing. And effectively, we have almost like a barren wasteland in the place where the vitiligo skin is. Now, both of these images I actually made on the AI software, and I'll talk a little bit more about some of the interesting artistic and philosophical concepts of vitiligo very shortly. But basically, the lack of dividing melanocytes creates this barren wasteland in the middle. So we need to ask ourselves, if this is what we are dealing with in chronic vitiligo, how do we address this? What we need is to bring life back. So there's two parts. On the left, this is acute vitiligo. How do we stop a new attack? We know that we're already behind the 8 ball. The moment we see this loss of skin pigmentation, we're seeing the manifestation of old pigment cells which have already been lost. We need to protect melanocytes early in this acute phase. And that means, just like Monisha mentioned earlier, we need to start treating vitiligo like a dermatological emergency. We need to get onto treatment quickly. And we need to do things like antioxidants. We need to find ways of reducing the stress in the skin, because the less signals the melanocytes send out to the body, the less likely the immune system is going to target them. Now, unfortunately, there aren't amazing evidence or research done in the antioxidant space. That's something I do want to look at in more detail. But everything from even turmeric has been proposed as having antioxidant properties, which may be able to lower the stress in melanocytes so that the secondary steps of autoimmune activity do not activate, or activate to a lesser extent. Now, on the right-hand side, how do we bring back this lush green, promised land, if you will? So this is the treatments that we were talking about before. So we need to reactivate the stem cells. In that barren wasteland, all life is gone. The trees are gone. Your ability to regrow another tree from a dead tree is going to be very difficult. That is what's happened inside the vitiligo lesion. Additionally, because the autoimmune activity may still be ongoing, any new trees that grow just get burned up immediately. So we need to create a nice habitable environment that we can get these melanocytes back to grow. We need to activate these stem cells, which there are both, what we propose, hopefully topical treatments, but also other physical treatments where we can potentially inject things into the skin to be able to activate stem cells. Using some of these proteins, both naturally in the skin and hopefully developed as a treatment as well, we can retrain melanocytes to become the type that actually can grow, which will allow us to have the trees and the lush greenery grow back into that wasteland, and to master the transplantation process. Because at the end of the day, if the entire space is barren, sometimes it's going to take a lot of effort to grow that forest back in from the outside. Maybe what we need to do is actually bring some seeds inside and regrow the forest. And being able to do that well and effectively and successfully is going to be very, very important. So this is what we propose: stop the stress, stop the death, and then bring back the light. So we're going to finish off before we go through a second round of questions, is actually talk about, oh, that's good. Oh, we've got to put it over there. That's genius. I didn't even realize that happened. So I was playing around with this to better understand, where the future of vitiligo is going to go. Where my idea came from was, a lot of people have been touting that, AI is the future, right? In 20 years' time, we won't have jobs anymore because AI is going to take all our jobs. Now, I thought, okay, maybe AI isn't necessarily the future, but maybe AI can predict the future. Now, people have often tried to ask, things like ChatGPT, which you might have heard of, about, can you predict what's going to happen in the future? I thought to do it a little bit more visually, because vitiligo is a very visual disease. It's something that, often doesn't affect our health, but affects how we socialize. It affects our mental health. It affects so many other areas of our lives, which, one of the reasons why I'm in dermatology is because no one cares about it sometimes, which is pretty bloody frustrating, right? Life is not just about whether or not you're alive or dead, as cardiologists would think. Life is about how much quality that we can derive from each and every day. And sometimes it's important for us to feel as good as we can in each and every step that we take. So I thought, okay, what does AI think about this journey? Where is the future going? I basically asked AI to repeatedly recalculate the word vitiligo and create a new image based on the previous images as created. And I asked it to do it again and again and again. And you can see that, AI clearly doesn't know what vitiligo is right now, because it thinks that AI is just, almost facial makeup at this stage, just covering it. But you can see that, you know, it has a general gist that there is patchiness, right? And it often affects the face, and it often affects people of darker skin color because it is more noticeable. But what I noticed was something very interesting. When I repeated this process many times, AI eventually forgot about the vitiligo. After many iterations, the vitiligo no longer existed. And in fact, patients just had, you know, skin with tattoos on it. And what that kind of manifested to me was that the future of vitiligo is the treatment and cure for vitiligo. And while right now on the left-hand side, it might not look pretty, it might not feel pretty, in many ways it is very artistic. It is unique. It is part of our character, it is part of who we are, but it is part of the beauty that we bring into this world. And while this is something that waxes and wanes and changes over time, I think the future of vitiligo is that we will find a cure, and we will find a way for beauty to manifest in all of us each and every day. So at the top there, we start with vitiligo now, and we get to understand it more and more. And in future, with this better understanding, we can therefore advance this treatment to bring the treatment back to patients and bring the color back. That is what we're probably here to celebrate. So together, we will make vitiligo go away. I didn't realize that I had already put up this slide earlier and didn't make a comment to my terrible joke, but you know, I think that is a good dream. And you know, I'd really like to thank everyone for having me here today. I'll just leave up this slide. Well, hopefully everyone's already had a look at it. I'll leave it up there later, but thank you to everyone, particularly VAA, for the opportunity to present today. I realized I spoke for like 45 minutes, so a little bit longer than I expected, so my apologies. Thank you to my lab members and Adrian Ma and Mark Shackleton for all their support. Wouldn't have had the opportunity to know any of this or study any of this or present any of this without their support. Thank you to all the other lab members and the members of the Skin Health Institute as well for allowing me to come here in the vitiligo clinic and recruit some patients from here. Now, I'll leave that up on the screen. We are always recruiting new patients. So if you have a bit of skin that you're willing to donate, I'd love to come in with some biopsies in a very gentle way. I wouldn't do it too aggressively, but it is aggressive. Yeah, that's probably not the right term to use. But I think the future is going to be a collaboration, and I think vitiligo is a disease that hasn't really been studied in enough detail. You know, one of the things that I'd like to end on, which I tell a lot of my medical students and the juniors that I work with, is over the last 50 years, there's been 1,001 blood pressure medications, 1,000,001 diabetes medications. There's been so many things that have come out in other medical fields. But if we talk about how do we make pigment cells grow back, the only thing we have is the sun, UV light, right? We actually haven't found a way to make pigment cells grow again. And I think that's just a manifestation like Mohan was saying, you know, funding, where do people actually invest, and including, you know, pharmaceutical companies, governments, where is the money going? And I think now, you know, we are hopefully at a precipice where we can actually say, look, we need to make vitiligo the forefront of, you know, what we do as dermatologists and bring it to light to this community, to government, to pharmaceutical companies, and actually say we want to actually find the treatment that's going to bring this disease to an end.
We just had one last question here, and then we might end the Zoom.
No worries. Go ahead, Mohan, and then we'll go to your question next.
So basically, why is the area around the white patches darker than the rest of the skin? Is it because there's more concentration of pigments there?
Could you hear that?
Yes. So just correct me if I'm wrong. So is that why is the peri-lesional, so the area just around the skin, darker than the skin lesion itself?
That's
yes.
Correct.
So that doesn't necessarily manifest in every single patient. It can happen sometimes. It is dependent on a number of factors, including whether or not the patient's having treatment at the time or not. So for example, if there is UV therapy, there is a potential that the margin will become darker than the rest of the skin. Now, the question is, I guess, why is specifically that edge the darkest point, which does happen at times? We actually don't have the specific answer for that. But we know that this edge is a very, very interesting place in the story of vitiligo, because I imagine it almost like a battlefield where you've almost got, cells that are trying to invade back into the white territory, but the white territory is trying to push them out. And there could be a number of factors, including cells are dividing, cells are trying to migrate, but unfortunately the cells are not able to enter that territory due to some kind of unknown factors. And if the migration doesn't occur, then potentially you end up with more pigment cells right on the edge, and that might end up with a slightly darker color. And part of the research into vitiligo is understanding the multiple parts of pigment cell biology. So we need proliferation, we need growth, we need migration, we need it to move to the right location. We need adhesion, we need it to stick to that location so that it doesn't move around and it survives. Then we need melanin production, we need it to make pigment. And if any one of those 4 sections doesn't work properly, we won't have successful vitiligo treatment. And potentially the darker rim is because of that migration problem that hasn't yet been solved yet.
Thanks, Chris. That was a really insightful presentation, and we really appreciate you taking the time to speak to us. We'd love to have you back down the line to hear more of your progress in the research. We might wind up the online session, and we'll just have some local discussions at our venues. Thank you very much for everyone for attending our World Vitiligo Day celebrations in Sydney and Melbourne. Our next event is going to be in September, where we'll be doing a camouflage workshop. So you'll hear more about that through our emails. Thank you. Goodbye.
Thanks, everyone.
Can I ask a question?
Yes, of course.
I read one day that there was still like the 2% of the world population have vitiligo.
Yeah.
So now my question is nowadays, obviously probably it's growing to a bigger percentage. Is that because it's more now the research will be more, there will be more money for it because it's more important now to get to the to the bottom of the problem. Like you said, you're one of the few people who are very interested in it. I don't know how many.
Yeah, it's a bit of a conundrum. So basically, the way that drugs are developed is that a company looks for a condition that they think that people are willing to pay for it. And in the past, that has been things that result in earlier mortality. People were willing to invest in surviving an extra 20 or 30 years, and people are willing to pay quite a lot for that, and governments are willing to pay for that. So the reason why vitiligo is becoming a little bit more exciting for most people now is because a lot of the immunology advances that we talked about for let's say rheumatoid arthritis or some immunological problems now coming into vitiligo. So people are starting to understand that vitiligo is a treatable and addressable condition, but unfortunately, it's still very much focused about the immune system. And we know that many patients with vitiligo probably know that it gets to a point where you do as much immune suppression as you want, but the color doesn't come back because it's actually not so much about the immune system anymore by that stage. It's actually more about the pigment cells growing and the pigment cells functioning. Now we need to then actually take a complete paradigm shift and actually say, how do we make pigment cells grow? So pigment cells growing basically has 3 probably main areas that people will want to do research in. So vitiligo is obviously the first one that people are willing to kind of invest in, but the others are going to be skin tanning. If somebody who doesn't have vitiligo just wants to be a little bit darker, potentially that this is a treatment that they could use purely for cosmetic reasons. So if it works for someone with vitiligo, it might work for someone without vitiligo. And the other one is in burns patients. So often if anyone's ever had a burn before, this skin will heal because the protective layer, the keratinocytes, will recover, but the pigment cells often won't recover because the burn itself will damage the same cells. The same cells that are harmed in vitiligo are gone when you have a burn. And is that something that you...
Yeah, just a small one.
Yeah, same thing. And that will happen even in a patient without vitiligo. If you burn your skin hard enough, the pigment cells are gone, it will be a lighter color afterwards. So I think that's probably where the investment will come from when people have a better understanding of that. But the first, biologic drug for that has been used in vitiligo as well. But the first biologic drug took almost 20, 25 years of investment and time and billions of dollars to find the first one that worked. So we're trying to find the first treatment to grow pigment cells. So it might take a long time, but you know, the more that we collaborate together, the more that we have support from the community, from patients, I think the closer we'll get.